Hi, everyone. So on behalf of the program, I'll give a brief introduction of the program. So our program is called Stamina for Space, and Charles has said what it means, but I'll repeat it again. So it stands for Space Technology and Applications, Mastery, Innovation, and Advancement. So I know it's a bit of a mouthful, but just some background. The Stamina for Space program is a continuation of the Philippine Microsatellite program. So its goal is to build, launch, utilize the country's first microsatellite for high precision Earth observation. And so one of our main outputs is the first microsatellite. I hope you've seen it in the news. It was Diwata-1, and it was deployed last April 27, 2016, about 4 years ago. And we actually just decommissioned it about a week ago. So we also had Diwata-2. So the Stamina for Space program aims to capitalize on the gains of the previous program, because the first step was to build it. We built it with the help of Japanese professors. So we built the satellite. It was built in Japan. It was built with Filipino hands and scientists, but now we want to build things in the Philippines. So the Stamina for Space program is it's made up of 4 component projects. So the first 2 projects, they're for satellite technology research and development. So project 1, optical, it's for the development of a local payload, because the payloads of Diwata-1 and Diwata-2, they were built in Japan and they used components made in Japan. So, well, actually we'll still be using components not from the Philippines, but at least we would like to build it locally. And the next step would be, they're also looking for partners in which we can source the parts locally. And project 2 is PHL-50. They want to localize the building of the bus. And then the third project is technology know-how, project Step Up. So it's for technology and know-how proliferation, because during the Philippine Microsatellite program, most of the project components are in the University of the Philippines, Diliman. So it was concentrated in one university. So going forward, we would like to involve other universities, so it would not be just concentrated in one place. And the last project is the project for GRASP. So we launched Diwata-1 and Diwata-2, but we all know that the satellites someone has to operate the satellites. Otherwise, we built it and we launch it, and then it's just junk out there. So the project 4 is the operations team. So we manage the telemetry, download the data, and also distribute it. So why are we doing this? So I think I'm preaching to the choir here. So we do it for the data for scientific Earth observation, so that we can do it for evidence and data-based policies and programs for our country. And 2 is we're doing this to build an industrial base for high value-added activities, because it's not just about the satellites. So we can build the satellites, but there's also an ecosystem around it. So satellites provide jobs for the semiconductor industry, for universities, and everyone else. So right now, one of our teams is developing locally developed experimental modules. So we're also involving our local semiconductor industries, because they can produce some circuits, etc. But they're not space grade yet. And right now, they're not really incentivized to do it. So we try to lead the way. And also, one of the goals of the Stamina for Space program is to provide an environment for interdisciplinary research. So right now, we have a building, we call it Ulysses, and also Pedro. Ulysses is a microsatellite research building, and Pedro is the ground receiving station. That's the one in the bottom. And last but not the least, we're doing this for the people, because as we may know, here Here's a picture of the teams from the Philippine Microsatellite Program. So the satellite, building a satellite is not something a field can do it. And it's not something a field can do in its own. We can't just have mechanical engineers or electrical engineers. It is really a meeting place for everyone. So as you can see, these are the courses, the fields of the members of the program. So we have aerospace engineers, we have computer scientists, we have cosmos science people, we have physics people, we have space engineering people. So no field can really do it on its own. So we have to foster the people. So as Doc Joel, our previous project leader, keeps saying, when we build satellites, we don't just build the hardware, we build the people, because satellites are the king of systems. So you integrate many parts from different fields. And so going back, so we're doing this for the data, an industrial base, and to build an enabling environment for the people. So this is just an image of our distribution site. Just in case people here don't know yet, the data from the Diwata satellites is available to everyone. So you just need to sign up, because our funding agency needs to see the metrics and who uses it, but it's open access. So if you want to learn more about our program, you can visit the site here, phl-microsat.upd.edu.ph. And if you want the data, you can get it from data.phl.microsat. So we're also on social media platforms. So you can see us on Facebook, Instagram, Twitter, and you can also email the program. And here are collaborators. So we have connections with Kyushu Institute of Technology, also on Tohoku University and Hokkaido University in Japan. And we are funded by the Department of Science and Technology. And these are the universities that are part of the program. Partners of the program. So thank you for listening. Here's a picture of the team in one of our events. So thank you.
Okay, thank you very much for the presentation. I think we'll start with the panel discussion. But before we start, I'd like to shortly introduce some of the other members that are currently here. So I'd like to welcome Dr. Gay Jane Perez. Dr. Perez is an associate professor and deputy director for research and extensions at the Institute of Environmental Science and Meteorology, University of the Philippines, Diliman. And she received her doctoral degree in physics from the National Institute of Physics, also in UP Diliman. And afterwards, she pursued a postdoctoral study at NASA Goddard Space Flight Center. Her work focuses on the use of satellite data to study the environment and climate. She currently leads a project on agricultural drought assessment and forecasting in the Stamina for Space program. We also have two other members here. We have Ma'am Julie Ann Banata. She's a PhD student in aerospace engineering at Tohoku University in Japan. She graduated BS Electronics and Communications Engineering from University of the Philippines, Diliman. She worked in a private industry as a hardware engineer before joining the PHL-Microsat Program in 2016. And she's currently one of the few students left in Japan to pursue their graduate studies before coming back to the Philippines and help in the space efforts in the country. We also have Ma'am Mary Ann Constante, is a research associate and the lead engineer of the Step Up project under the Stamina for Space program, and she obtained their master's degree in electrical engineering at the University of the Philippines. She was part of the amateur radio payload development team for Diwata-2 and the ground sensor terminal development team for Maya-1's remote data collection system. She also assisted in developing courses and materials on space technology in the UP Electrical and Electronics Engineering Institute. In the past, she worked as a lecturer under the same institute and led one of the engineering teams for a government-funded research project on slope monitoring and change detection through sensor nodes. She also worked as a developer of a cross-platform software application development company. Um, and I would also like to acknowledge all of the other participants who are currently in the Stamina for Space program. To start the panel discussion, the moderators, would like to ask some questions. And for the people in the Stamina for Space program, please feel free to answer them. So the first question would be, what do you think is the importance of Stamina for Space in the Philippines? And how do you envision this program to contribute in the long term to the country's research and development? Hello?
Hi, Miguel. So I guess anybody can respond to your question, right?
Yeah.
Okay, so hello everyone. I'm Perez. So I'm currently the program leader of the Stamina for Space program. I just took over quite recently, just maybe a couple of weeks back. So from our former program leader, Dr. Joel Marciano, who is now the Director General of the Philippine Space Agency. So to answer the first question, actually RK, I think, already provided the answers to that in his presentation of what the objectives are of the Stamina for Space. So probably I'll just add a little bit something of my personal opinion on this in terms of how I see the program can contribute in the long term to the country's research and development. So I'll give a very concrete example, which is on the remote sensing aspect. So RK has focused, I think, on the satellite technology part. So indeed, we built a microsatellite, the first one for the Philippines. But I think what was new in addition to this experience is our exposure to analyzing raw data, raw images. So prior to the PHL-Microsat project, we are used to getting images, say, from Landsat, from ODIS, as many of you have also experienced. And you know that this data are analysis-ready format, so it's quite easy to analyze them. You use GIS software or other image processing tools, and then you can extract information out of it. But with building a new satellite or our own satellite, we are not just data users, we are data producers. And the data that we are working on are raw data or level 0. And it's the first time that we experience, trying to reference it, because when we download the data, it's not automatically overlaid on a map. So we have to figure out how to do these things. So what I'm trying to say is, I think it creates a different kind of opportunity to our remote sensing researchers and scientists to learn how to develop algorithms for product development. And I can see that this is a good foundation to actually develop more remote sensing products for different applications in the future. So just one aspect of the Stamina for Space project that I want to highlight. So maybe others, I can see Julie, Nan here. So maybe they have a different perspective as well, based on their own experience.
Okay. For me, I'm gonna, as a student that, one of the students that actually developed the bus system of Diwata-2, I think what the main part for me that Stamina for Space can contribute is actually the change in mindset and the students and young professionals in the country. Like, even to these days, whenever I talk to people and when they learn that we actually have space technology in the Philippines, they are very, very surprised. Like for example, when I was growing up, I've always wanted to be like, space is a very cool sector to work on. But living in the Philippines, it was next to impossible to find a job related to space because we know NASA, we know JAXA or ESA for Europe. But if you want to still be in the Philippines and work on space, it's just not existent. So when the program started, it opened an avenue for students like me. And even if when we talk to other students in the country, like um, uh, it provides an avenue that, okay, for the future, if I want to work in space, if I want to study space, then there's going to be a job waiting for me. So that's my perspective.
Hello, hello everyone. Uh,
Maybe I could interject because the next question is actually related, and it's goes straight to the young scientists on the programs. Maybe as we're responding to the first question, you could also respond to this one. As you young scientists, researchers, what is the biggest challenge in participating in such a project? Yeah.
Okay. Actually, my answer to that is also the change in career, because I think unlike some of the other engineers in the project, like they were already working in UP. They were still based in UP. And then when the project started, so it was a project in collaboration with UP. So most of the engineers and scientists that works in the project are sourced from UP. For me, I heard about the project when I was still working in the private industry. I was actually already having a great career in that area. But when I heard about that we launched our very first satellite, the Diwata-1, I really wanted to contribute to those efforts in the country. So I had to decide, should I give up my current career and join a path that I have next to zero knowledge with, or just watch them go do it and stay safe with my current career. So since I am here right now, I took the leap. So it was one of the main challenges that that I had when joining the project. Yeah.
Okay. Yes, Anne, you were saying something?
hello.
Yes, we can hear
Yes.
you.
I would like to apologize in advance because my internet connection is quite intermittent right now. So earlier,
Okay.
I was only able to capture 10% of our case presentation. But first, may I acknowledge one of the team members of the Step Up project, Carlo Pastoral, who is currently in National Cheng Kung University for his master's degree. Hi, Carlo. So I'm Mary Ann from the Step Up project, which is short for Space Science and Technology Proliferation through University Partnerships, which is under the Stamina for Space program. And our team is assigned on making space science and technology more inclusive and accessible in the Philippines. And we do this by partnering with different institutions in the country through building a local consortium on space science and technology. And also by offering local opportunities for satellite development in the form of graduate program. And this involves hands-on development of satellites, which will be launched to a low Earth orbit. So basically, I think the significance and main contribution of our team in the Stamina for Space program and in the country's research and development endeavors is that we are opening the doors to different sectors in the country to get involved in different space activities, and also in building the human resources that hopefully in the future will be capable to execute and lead the country's space research and development activities. So I think that's it for the Step Up project.
Okay.
Thank you.
Thank you. Thank you very much, Anne. Yes, Miguel.
Okay. Yeah. Thank you very much. I think Ma'am Gay actually mentioned some of the answers that I'll be asking next. So, like their first experience with having a level 0 data set that they would georeference themselves. So my question would be, what are some of the most memorable moments in the research for this project and some of the highlights that you would want to share with the rest of the viewers right now? Hello?
Yes, hello, Miguel. Yeah, maybe we can start with the young ones,
Okay.
the younger ones. RK
Yes,
maybe,
please feel
or
free to answer for anyone. The question is for everyone on the team.
okay.
Okay.
So I'll give the floor to our young researchers first.
I think we forgot to acknowledge another team member who is currently in Vienna. So Mark is here. Mark Tupas, hi. So please feel free to answer as well if you want, if you have anything to share.
Hi, hello everyone. I'll try to chime in later.
Hi, Marks. How are you? So actually, for us, this is also maybe a rare opportunity to see each other. I haven't talked to Marks since he left the country, and also to Julie. And I see Carlos is also here, and he's in Taiwan. So we are all over the place. So thanks, Chef, for organizing this. I haven't uh, talked to them in a long time. So this is a good opportunity. Anyway, I think RK is trying to say something.
Okay, yeah. I'll just to answer just take a stab at answering the question. So the question is, what is the most memorable or the highlight of a research work in the project? So I started at the program when it was still the Philippine Microsatellite program, and like Doc Gay said, we we're used to remote sensing. We're used to making the data. I mean, to using the data that agencies like NASA has provided, USGS. But with the program, we were able to produce the data ourselves to make our own data. So there are many guides to using Landsat data, Sentinel data. It is really well documented. But when we started with the program, there wasn't really a lot of documentation on how the sausage is made. So when the data comes to us as remote sensing practitioners and users, the data comes in TIFFs, right? But when you're the ones operating the satellite, it comes in binary formats, space packets, and well, we're not really familiar with that, and then you have to transform the data. And like Doc Gay said, the Landsat data, it comes georeferenced already, but when you're you're producing the data yourselves, the data is not georeferenced, it's just an image file. So, and well, there's a fun fact about microsatellites. Their pointing accuracy isn't really that good. So, yeah. So in Landsat, it's georeferenced, but when you start with the raw image and your pointing accuracy isn't that good, well, you could be off by a few kilometers. So good luck finding that. So it's actually the most memorable achievement for me is when we finally were able to publish the data, because when there are so many steps that go into producing the data that right now I'm really grateful to the Landsat people. I mean, I appreciate their work more now because you georeference the data and then you take care of the distortions and then you radiometrically calibrate the data, and then you also, well, actually the georeferencing was the most annoying part for me. But yeah, I think the most memorable part was when we were finally able to make the entire pipeline from getting the data and then shipping it to our users, because that's the part without a lot of documentation, because we deal with the finished product mostly, and now we really know how to do it. And also we really appreciate now the amount of work that it takes to make those data sets that we freely enjoy. Thank you.
Okay, thank you, RK. Julie, you have anything else to add on?
Yeah, for me, since I'm on the side of the actual building of the satellite, I think my most memorable moment is when we were writing our names on the ARU unit before attaching the final panel of the satellite and then delivering it to JAXA for launch. Since we built the satellite for like the actual building took months, I think. So we did a lot of vibration tests. Every after vibration test, we would disassemble stuff and then assemble again, which will take a lot of sleepless nights. So like when we attached the last panel to the satellite, the realization came that this is the final screwing of bolts to this satellite, and then we are already like it's already finally finished and we're going to give it to JAXA for launch already. So that moment was the culmination of months of hard work, of design, of testing. So yeah, that was the most memorable moment for me.
Thank you, Julie. Maybe we go to the next question, and anyone can feel free to ask to answer this one. So it is, what is your experience working with researchers from Japan, and what are the main differences on how they do research with the way you do your research? Yes.
For me, I think the main one, actually for the people, it's almost the same. I mean, for Japanese, they value time the most, but at least the main difference when I compare the Philippines and Japan is actually the environment, which is very conducive for research. Given the fact that they have the expertise in satellite technology that we don't have in the Philippines for now. One other is, for example, if we want to create a prototype for a certain part of the satellite, we can just order it online and then it will arrive the next day and we can immediately assemble. And then for testing, the facilities are already there. Like our professor would just book it on the day and then we can test the next day. So the turnaround for research is very fast. There's no waiting time. If you have something to test, you can build it already, you can test immediately. But in the Philippines, I don't have much experience since I haven't been based in the Philippines as a researcher. I think Mom G and RK can expound on that more. But at least from what I hear from my counterparts in the Philippines, for example, when they were building the ARU, the amateur radio unit which was built in the payload is built in UP, they would always complain, okay, this part we need it so that we can integrate it to the actual unit already, but they need to wait not only weeks but sometimes months for a certain component to come because of procurement laws and stuff. So I think yeah, that's the biggest difference.
Okay, thank you. Yes, Dr. Gay, you have anything to add on?
Okay, actually, I would like to hear Man, since Man has good interface with Japan team and also the local team that Julie was trying to explain earlier. So maybe Man can give her or share her own experience.
Okay. Thanks, Ma'am Gay, and thanks, Ate Julie, for sharing your experiences in Japan. So as far as the local development team is concerned, the ones that is mentioned by Miss Julie is true. When we are developing the amateur radio unit for Diwata-2, it took us around 5 to 6 months before we were able to access the components that we needed to develop the satellite and the payload. And the difficult part there is that when you need to change the components, because after some tests you find out that it's not working, it's difficult to purchase another part or a replacement component. And so actually, some members of the team during the development time had to shell out a significant portion of money just to cover the expenses and buy immediate replacements for the components. And as far as the testing is concerned, since right now the Philippines do not have the enough facilities to conduct space environment tests, we also have to go to Japan to conduct the tests. And there are a lot of shipment challenges, bringing your satellite to Japan and bringing them back to the Philippines because of export restrictions, and also the transport of the people that will conduct the testing is also quite expensive. And if there are global issues that are being encountered, just like right now, we are having the COVID-19 pandemic. So supposedly the team that are developing the cubesats here in UP Diliman, they are supposed to conduct their space environment testing, but it was postponed indefinitely because there is a travel restriction from the university, and Japan also suspended the visa of Filipino travelers to Japan. So yes, as far as research output is concerned, there's quite a lot of delay in executing the activities to be able to produce the output that you need. Thanks.
Okay, thank you very much. I guess we can now proceed to the question and answer portion. But before that, I'd like to acknowledge that Mr. Carlo Pastoral is actually my roommate. And he's currently in the same room with me. So,
Thank you.
Okay.
so okay, let's start with the Q&A. I think we have some questions in the chat box, and I think some of them were already answered by Dr. Perez. So there's one here. I'd read it from, I'm sorry if my pronunciation is wrong, Biplov Bandari. His question is, do you have technical documentation on converting raw images to ARD with all intermediate steps?
Yes, we do have these technical documents together with ATBDs or algorithm theoretical basis documents. But as of the moment, they are for internal use. I think the group of RK are still working towards maybe making some of them accessible online. But right now, these documents are being used by the team that process the satellite. And I must say, we have to create these documents because this do not exist. It is our own satellite built by our engineers. So this have to be translated. You know, so we are the ones creating this technical documentation. So maybe RK would like to add to that.
Hi, thanks, Doc. As for the technical documentation, yeah, we do have them, but right now we're not sure yet if we can share them. We're just seeking clearances yet. And one of the, I think, I'm not sure how much people can learn from them because of as Gay said, it's mostly, the satellite is custom made. So I'm not sure how much of it would be transferable, but the general methodologies, like what, by the way, we focused mostly on open source software because we wanted to in our hubris we tried to automate everything, and we mostly failed at the automatic georeferencing part. That stuff is really hard. So, but for all the rest, so like we used Python. We were able to do it in Python with without paying for any licenses. So In that part, I think we could share that. We actually have a paper on that at ISPRS. So we will update you if we were able to get clearance for sharing this. So thank you.
Okay. There's another question that is on what is the coverage of Diwata-1? That is in terms of area. That is from Mohammed Abderekada. Yes.
Hello. So I
Yes.
guess I'll answer this. So as last time we checked, Diwata-1 covered roughly 38% of the Philippines. So during its lifetime, so Diwata was about 4 years old. So it was only able to cover 38% because the Diwata swath is a bit small. So yeah, I hope that answers the question.
Okay,
So
thank you.
38%, about 114 square kilometers.
Okay, thank you. Sir Aranas, I think there was a follow-up in the chat box. The question earlier, the person who was asking the question earlier was asking if you can share the paper that you have mentioned, or maybe how they can contact you besides from what you have shown earlier. Sir, I think your microphone is on mute.
I'll share it as soon as I find it. It's in the ISPRS archives. I'll have to look for it first.
Okay, thank you. Everyone, the floor is still open for questions. Does any other have questions?
I have a question.
Yes,
First, well done, guys. It's beautiful what you've done and very motivational. And I have, from the first presentation, you mentioned a lot of different professions of jobs, people from different disciplines that contributed. And I saw that you have environmental scientists and remote sensing. So because I'm very passionate about science, space science, but I am a geomorphologist with remote sensing skills. Where is the place of people like me in the development of because you did everything and it's beautiful. So I'm very interested in to know if there is a space, what is the place for environmental scientists in this chain from the conception to the actual analysis ready data. So do we stand at the beginning and at the end, or also in the middle of the development?
Okay. Hi, Nicholas. I'll try to answer your question because I'm an environmental scientist.
Very good.
Myself, well, my background is physics, but I'm now with the Institute of Environmental Science. So I'm carrying the environmental scientist hat here. So where are we located? Where do we find us? So you're right, we're actually at the start and at the end. More of the start and the end. So so our team is involved from the very start when we were crafting the mission of the satellite. So because the mission has to come from the scientists, from the users, which is represented by scientists. So we did our consultation with the stakeholders. We know what kind of data they need, okay? And as remote sensing scientists, we know what kind of sensors will probably provide that kind of data. So that originates from the science team. So we communicate it to the engineers to translate it to satellite specification or requirements. So then they build it, they do the engineering aspect of it, building the satellite. In the middle, actually, I find myself also partly involved, our team partly involved in the middle, because when they were testing the payload, the cameras, they are in constant communication with us to see if the performance, say the radiometric accuracy is acceptable. Or are they getting the ideal signal to noise ratio? So there's still some inputs in the middle, but I think more of us are involved towards the end, and that's the product development. So once the data starts coming in, so we develop algorithms, say you convert level 1 to level 2 or level 3, like from the georeference radiometrically corrected images, you want to generate surface reflectance products, and then come up with water products like chlorophyll and so on and so forth. So that involves a lot of remote sensing. And in our case, our team from environmental science was heavily involved in that part. So I hope I answered your question.
Perfect, but I actually have another one now that you made me think. I looked it up, Diwata-2 in internet, and I saw that you have an optical multispectral instrument, but I couldn't find the specification. I only saw that it's a tunable, liquid crystal tunable. Does it mean that you can actually decide from the ground the bandwidth and the wavelength of all your spectral bands? Is this the case?
Yes. So it's a liquid crystal tunable filter. We can select from the ground the wavelengths, the central wavelengths that we want to use. The bandwidth is pretty much already set.
Okay.
So yeah, so you just move from 400 plus, maybe 450 nanometer to 1050 nanometer. So it's from visible to near infrared. We can select the wavelengths. We normally operate 12 at a time. And we can do experiments. We can choose which wavelengths we want to use.
Very good. So it's 12 bands.
Well,
it depends.
That's our operational use of it, but actually we can do more if we want. It's just that there is also a trade-off in the overlap area because the satellite is moving. So if while you're switching from one to the next, so after some, you would not be looking at the same target anymore, if you can imagine.
Push broom?
No, it's just an imager. So it's not push broom.
It's an imager. Yes, okay.
So, but the satellite is moving, so you switch from taking snapshots. So after some time, you will miss the target. So that limits somehow how many bands we can use when we try to switch and choose the bands. So, but technically we can do more than 12.
Perfect. Thank you very much. Congratulations again, guys.
Thank you.
Okay, thank you, Nicholas, for the question. And Dr. Perez, do we have any other question from the audience? Any comment? Yes, any question or any comment? Anyone from the team who has anything to say that might have skipped your mind that you want to put it across right now, you can go on.
Charles, there's a question in the chat box.
I think it talks, this is Mohammed. I think he wants to say, what about the life cycle? Is that for the Diwata-1? It's, maybe you can specify, Mohammed.
Thank you, Charles. I'd just like to say that for those who are asking questions, feel free to unmute your mic. You can ask them directly to the speakers. Okay, so there are some cases, well, he can't. So can anyone answer to this question? Hello? I
RK,
think,
you want to answer?
Yeah, I
yeah, the
think
life
Sir Marks.
cycle, the
I
satellites.
think Sir Marks would like to say something.
Okay, hello everyone. I'm here in Vienna, not in the Philippines, so I'm a doctoral student here in TU Wien. I was part of the program for the longest time, so everybody's my colleagues back home. So the life cycle of the Diwata satellites are very, in a way, it's very short because they are microsatellites, and it's actually dependent on how each satellite was actually launched. So, for example, the Diwata-1 was launched from, or it was deployed from the International Space Station. So it was at a very low orbit at about around 400 kilometers. So it basically has only a lifespan of about, the projected lifespan was about 2 years or so. But fortunately, due to the favorable space conditions, it lasted for about 4 years. But for example, Diwata-2 is actually at a higher orbit now, so it's at around 600 kilometers. We don't expect we don't expect its orbit to degrade as fast as Diwata-1. So we're hoping to get around 4 years of life out of Diwata-2. So it's a good thing that Diwata-1 and Diwata-2 has an overlap. So at least we have continuous use of our satellites. So we're hoping that perhaps before the fourth year of Diwata-2 ends, we'll have another one up there as well. Okay. I hope I answered the question correctly.
Yeah. Thank you.
Can I ask a question?
Yes, Cheryl.
So actually, before I ask my question, the very reason that we wanted the team to be here is because I think it's a very unique project. It's coming from a developing country. I think it's a good example of like creating your own microsatellite. So maybe my question is, why did you choose to focus on developing small satellites? I know that you're not just working on microsatellites. So maybe aside from the cost, can you provide us with some insights on why develop small satellites and what could be the potential advantages of this kind of efforts, especially say for other developing countries who might be interested in developing their own small satellites?
Che, thanks for your question, but I'll actually want to direct that to Mean because I know Mean actually did a thesis on that, Mean, right, Mean? On lean satellite system. So maybe you're the perfect person to answer Che's question.
I'll try to answer that question to the best of my knowledge. uh, I think one of the questions was why we selected a small satellite in the development. So first thing, in the Philippines, we still don't have, when we started in the program, we still don't have the knowledge and expertise to actually start developing satellites. So there's so many things that are new to us. We are not familiar with space environment testing. We are not familiar with the requirements for developing a satellite that will survive space conditions. So right off the bat, it's pretty much obvious that we cannot go to a large satellite because there are so many risks in developing larger satellites. And also there is this, you mentioned earlier that there is this cost in the development of the satellite. And small satellites are actually more accessible if you are interested in learning space science and technology and in developing satellites. So Ma'am Gay mentioned earlier the lean satellite philosophy. So this is a philosophy that is uh, the lean philosophy has been existing in the industry. And there are some initiatives in the past years to apply this philosophy in developing satellites. And the lean philosophy, in summary, is a development approach by which you are targeting to develop values to your stakeholders or to your customers at shorter delivery time and smaller cost. So in the case of the Philippines, developing lean satellites will be very applicable because we will be able to provide value to the Filipino, to the country, in a short timeline and at significantly lower cost than larger satellites. And as far as the benefits of small satellites, um, since their cost is smaller and their development time is also shorter, you can form those satellites into a constellation and address some of the capabilities that can be done by larger satellites. And also, since the cost of the small satellites are smaller, the risks in development is also smaller. So I hope that answers the question well.
Yeah, I think that was
Thank
a
you.
very good answer because I think for many of us, we have heard of small satellites, but we're not really familiar why people are choosing it. So thank you very much for that good insight.
Thank you.
Okay, thank you, Cheryl, for the question, and Mary Ann for the answer you've given. Miguel?
Oh,
Yes.
yeah, I think one of our viewers also has a question. I think question or suggestion, Mr. Carlo Toral.
Hello.
Yes.
I think this will be a good opportunity to share what I am doing and then also ask somebody, especially Mom Julie Ann from Japan. Hello. So right now I am working or I am studying my master's degree here in NCKU, and I am working on a remote sensing payload of our satellite. Our satellite is a 4U CubeSat, and we plan to employ an artificial intelligence on board that will segment some objects that we are interested in. And right now, my current project is on. I'm developing or we are making our own data set for this purpose. So we are masking satellite images from Sentinel-2B, and this data set we're going to use it on for our own neural network on board. Yeah, so right now we are on development stage of this project, and I might as well publish this as like open source, or it depends on my professor's discussion with me. And also, Ma'am Judy Ann, I think I remember we had a meeting last time. So I think maybe we can have another discussion for this because maybe I can share you what I am doing right now, or maybe you need my help for this. Yeah, that's it.
Okay. Okay. Thank you. I think that's what Carlo wanted to share. So, so does the team have any reaction towards Carlo's suggestion or sharing?
So, Carlo, I'm so glad to hear about what you're doing. So,
Thank you.
I understand you're creating maybe the training set, right?
Yes, yes,
Using the Sentinel-2B
yes.
data that your neural net would use and later on load it to your satellite for the automatic identification, right? So, yeah, as I said earlier, to share, I'm glad that she put this virtual room together because now Carlo can ask Julie to,
Also, I
to
would like to
set for a
ask.
meeting. So, Julie, I think Carlo wants some of your advice.
Yes. Also, ma'am, I would like to ask if you have uh, data sets for this purpose, because maybe we can use it.
Yeah, I think, well, actually not our group, but I believe our case team at some point also collected some training data for, I think the objective before is to do the automatic georeferencing. So Arcane, do you want to add to that? Maybe you can provide some details.
Hello. Hi, Carlo.
Hello.
So in the data processing team, the previous Microsat program, we did gather data, but it was mostly for the purpose of georeferencing. So we mostly used the feature extraction. So we didn't really do a lot of machine learning yet or artificial intelligence. I think you might want to talk to the Datos folks at ASTI.
Oh,
They're
yeah.
the ones that specialize at that. So I think they're using deep learning now for inventories and stuff.
But
So I'm afraid we can't help you right now yet.
okay. Are you also, you mentioned that you are using your data for automatic georeferencing. Do you have plan to employ it on board the satellite?
Right now, no, because the grasp team, for example, we're pretty downstream. So we're with the data usage and distribution. So maybe maybe Mayan can answer, or
Okay.
Julie.
As for the step up, the cubesats that we are developing under the step up team, the missions of those cubesats are mainly on the communication side. And if there are optical missions involved, they're only using small cameras and only for technology demonstration. So I think the fourth generation of the BIRDS project that is being implemented in QTech incorporated camera with automatic detection in the satellite, but I still don't have the details of that design. And I also think it's only mostly technology demonstration yet. So I'm not sure if that will be helpful to Carlos' team. But
Okay.
yes, but we can set a separate discussion regarding that, and I'll also invite members from the Birds team for that.
Hi, Carlo.
Okay.
I just
Okay.
remembered something. There's an initiative. I forgot which specific company. It's called SpaceNet. So it's they're trying to build a corpus of satellite imagery for for machine learning application. So it's related to, there's trying to build something like, if you're familiar with the ImageNet corpus in machine learning, they're trying to build that but for space. So maybe you can find lots of data sets there. I think those data sets should be labeled already and ready for training. So I'll share the link as soon as I find it. I just remembered. It's SpaceNet.
I think I already found it now. Thank you. Thank you.
Yeah, there's also Big EarthNet. It's I think the same thing, same concept, but specific for Sentinel-2. I'm looking at doing deep learning too with Sentinel-2. That's why. But SpaceNet looks bigger, just like you said, RK.
Yeah, maybe I explore this data set for some time and do some exploration for their data.
Thank you.
Yeah, thank you.
I think, Sir RK, you can also share it in the chat box, the link that you have mentioned.
Hello. You just shared it on the chat
Yeah.
box.
Okay, so are there any other questions on the floor? Anything you want to hear from the team? Okay. Okay, so I guess, let me check. Okay, so I guess there are no more questions. I personally have a question on behalf of the ISPRS SC, and I would personally love it if everyone on the team could answer, because I think everyone here right now have different roles in the Stamina for Space program, and they all have their own different focus in terms of what they are doing to the program. So the question is, to students and aspiring young professionals, what would be your advice or any words of encouragement to us all?
Okay, so I guess I'll start. So I always say the same thing for students to really work hard, well, study and work hard, and dream big. Like maybe like what Julie experienced. So before, she has a dream to do something related to space, but it's not. There's nothing like that in the Philippines until this project came about. So we present this opportunity to the young researchers in the country. So I hope they will be inspired to pursue fields related to space science and tech. As RK mentioned, there are a lot of disciplines that can be involved. So for as long as they are hardworking students and are very passionate, so they can always be part of this project. Yes, so I guess that's what I can say.
Okay, thank you, Ma'am Paris. How about the other members of the team?
Hi, Miguel. I'd like to answer on the part of the Step Up team, since we are the component of the Stamina for Space that's already on the stage of building the human resources for the future space industry in the country. So on my side, since we're already interfacing with people that have the interest to develop satellites, so it's not much on the encouragement already, but in setting their motivation in developing the satellites. And something that we always tell to the group, since the development and launch of satellites remains expensive, activities like this for a country like the Philippines are only made possible with the government support. So essentially, the satellite development is a project of a country and its citizens. And while it sounds great to be working on the satellite, and sometimes the attention that you will get can be overwhelming, there is also a lot of hard work and patience needed to complete a satellite. So above all the personal reasons for joining a satellite project, we always tell our young engineers to always be aiming to seek and solve problems that will help their countries to a better future. So that's something that we always tell the group developing the local satellite in the Philippines right now.
Well, thank you. How about Ma'am Julianne?
Uh, uh, for me, my message, especially to students or young professionals, I think a lot of those of us that are interested in space would like to become astronauts. But for those who doesn't have a chance to be astronauts, Your message is the next best thing is to send something that you designed in space. So come join us.
Interesting. Sir RK?
Hi, Miguel. So, I think they already said a lot already. So, I'll just do my best to add something. So, as I've mentioned in my presentation, and building satellites has many different fields. So, we start with where you are now, and then in your subfield, for example, in environmental science, there will be a subfield there that is closely related to satellites. So I think we should try to build our skills there so that, for example, your country doesn't have a space agency yet, so you'll be prepared for when it comes. So I think the low-hanging fruits, for example, are you can check for open source tools for example, for image processing or for processing raw satellite data. There are specs online, like for the space packets. There's an international spec for that, so maybe you can try to read up on that so that you will be well equipped when the opportunity comes. But as Mayan said, it's really dependent on your country's government, so you can only do so much on your own. So I think the people here, oh yeah, one other advice would be to join communities like this, because you might not have opportunities in your country, but you might have opportunities in other countries or some PhD opportunities. So that's all. Thank you.
Okay, thank you. Yeah, I think everyone here would be interested to know about all the opportunities that are happening worldwide. And I think finally we have Sir Marks. Sir Marks, do you have anything to say?
Thanks, Miguel. Probably since I'm also a student again, so my perspective is quite shifted now compared to when I was working with a program. But I think the perspective is that as students, even if you don't know where we're going in terms of the research that you're doing, even if you don't know if what you're doing is going to contribute to the bigger scheme of things, I think you should always push through and try to do your best, as my colleagues has mentioned, because you really don't know how it would impact other people. So, for example, we started with Philippine Microsatellite Program in terms of novelty, in terms of being like cutting edge or bleeding edge. We didn't really do anything that much in terms of, maybe contributing new knowledge to the broader pool of knowledge. But in a way, even if it's not that very good academically, it has a big impact to other researchers and the younger people. For example, the program has like encouraged a lot of other people in the country that thinks space is not achievable for them. They tend to like see it as a new career path. And like another thing that the Microsat program and the Stamina for Space program has given like good, um, it has like been publicity for remote sensing as well, because a lot of people in the Philippines doesn't really know about remote sensing, and then when they heard about Diwata-1 and Diwata-2, that it actually captures images, they become interested with the satellite imagery, and then from there they get hooked. And we actually had some experiences where some layman would just look at the Diwata images, and then we're going to introduce them to like Landsat, to other images, and so on and so forth. So even if you think what you're doing is not important or just small, maybe the message is just keep on working and keep on pushing through. I think in the end there will be something that would come out of it. Yeah, maybe that's it.
Thank you very much. Thank you everyone in the team. I guess everyone here has appreciated those advices and words of encouragement. And I think this is a wonderful opportunity for everyone to um, have an idea of what's going on in the PhilMicrosat in the Philippines, the Stamina for Space program, and maybe some partnerships or friendships could possibly lead to it. So